There we go. Yeah, this week's lecture is on Intro to Blockchain. So we're just going to do a very general overview of what blockchain is, what does a blockchain look like, and some applications and values of the blockchain. And a lot of stuff that we talk about today, we're going to dive into it way more sometime down the line. So we have upcoming lectures like mining, about cryptography, about consensus that dive further into some of the topics I talk about today. So today really I just serve as a general overview to kind of outline what a blockchain even is. So speaking of that, what is blockchain? So blockchain is a shared immutable ledger for storing information, recording transactions, and tracking assets in a particular network. That may sound really confusing. In a few slides, we're actually going to dive into each of the words, like all the words that are highlighted, we're going to dive into them and discuss what they mean. But right now, information is basically what's stored, right? Like blockchain is a way to store information, is a way to securely store information, and information includes money, includes insurance, supply chain records, medical records. So these are more of the intangible things. But what we've noticed so far is that blockchain can also store tangible assets, right? Like real estate deeds or like art. So it's very interesting to see like the different assets that can be tracked on the blockchain. So to give a brief overview of the history of blockchain. So in 1991, Stuart Haber and W. Scott Stornetta invented the idea of blockchain when they produced a report specifying how time-stamping documents can be used in a append-only data structure protected by cryptography. And so that's when blockchain was first created. That's when the idea of blockchain first started in 2008. I think we all know Satoshi Nakamoto. He produced a Bitcoin white paper that referenced Haber and Stornetta's blockchain structure and added an incentive layer and proof of work consensus to create this digital currency, right? So blockchain at its core is a technology. What Nakamoto did was he made it into a currency by adding this proof of work and incentive. In 2014, blockchain became separated from Bitcoin. Its potential for other financial transactions is explored. So Ethereum was born and introduced computer programs into the blockchain, which became smart contracts. And right now, blockchain is one of the most exciting technology developments. Its use case expand beyond finance to include healthcare, supply chain, insurance. It also creates brand new field of finance called DeFi to compete with traditional finance products and services. It's honestly very interesting. I have a lot of financial involvement in every meeting that I take with anything with relevance to finance, people bring up blockchain. So it's very, very cool to see how like widespread this is compared to just a few years ago. Very, very interesting developments. So the point of this slide is really to highlight that blockchain is not a new invention, right? Like it's not this not secure, random, like little fad that's just happening. It started in 1991, right? It started before Y2K. It's been around for decades and has actually survived the test of time to prove itself as one of the most secure methods for storing information and recording transactions, right? So it's not just Bitcoin, it's not just this DeFi, right? Like it has a long established history. So overview of blockchain, I said we're going to dive into each of the words and what they mean. So let's do that. So shared. So blockchain is decentralized. This means all network participants have access to a distributed ledger and its immutable records of transactions. So all participants have a copy of the blockchain, allowing them to mutually verify the authenticity of the transactions. So basically you can, or a better way to put it is that you can have a full copy of the blockchain, right? If you run what's called a full node, we'll talk about that a little bit more in the second lecture about consensus. But essentially blockchains are decentralized and anyone can access the information on the blockchain if they wish. Second part is immutable. So no single participant can change or tamper with a transaction after it's been recorded to the blockchain. So if a transaction is erroneous, a new transaction must be added to reverse the error. So I can't say I'm going to backtrack it. Like I can't like delete what I said, but what I can do is I can make like a version 2 essentially saying, oh shit, that one was wrong. Here's a new version that's actually right. So there's no backtracking. The third part is the ledger. So what's a ledger? Ledger is a book or collection of accounts to record transactions. It's similar to a ledger. Blockchain is similar to a ledger in that we see, similar to a ledger that we see in accounting, except it has unique characteristics that can record both tangible and intangible assets, right? Like what we see accounting ledger do is mostly recording tangible assets, but what blockchain can do is also recording the intangibles. So it's very interesting there. We're going to talk about a little bit more about ledger and how it competes with traditional ledgers a little bit down the line. And The last part is assets. So what are assets? So assets includes information, transactions, and assets. So these are comprehensive examples of what the blockchain can store. Finance, for example, is just storing how assets and debts and credits are distributed, right? So that's all it is. 80% of the money we see today come from credits, and we need a database to store how the credits are distributed, and blockchain does that, but way better. So medical records, real estate titles, boats, arts, they're all examples of assets and information the blockchain can store. So the point of this slide really is to show that blockchain isn't just crypto, right? Like blockchain can store any information, any transaction, any assets at all. So it's very interesting to see like what else comes from blockchain, right? It's not just crypto, it's not just DeFi. There's, even though these are very, very exciting fields and very important fields, it goes beyond that. It really is just a method to store information securely. So blockchain versus traditional ledger. So why would we prioritize blockchain? Like why would we prefer that? So one, there's no intermediary. It's cryptographically, oh wow, I can't speak, secure. We're going to talk about that more in the second lecture. It's decentralized, transparent, and has technically fast transaction speed, right? That depends on what blockchain you use. Some are faster than others, and it's global. Whereas a traditional ledger, it's intermediary needed. So you need a middleman to kind of show how the ledger works, to store the ledgers themselves. It could be hacked. So it's not backed by cryptography, and it's centralized, it's opaque. So not everyone has access to the transaction. Not everyone can see what's going on. It's oftentimes very opaque. The speed depends on the intermediary. Some people work faster than others, but like, I don't know if you ever sent a wire transfer, it takes quite a few days. So it's not very fast at all. Whereas like if you're sending transaction through, I don't know, like the Bitcoin Lightning Network, it gets there in seconds, right? Or like Solana or Ethereum gets it pretty fast. And lastly, it's mostly localized. So these are some of the advantages for blockchain compared to traditional ledgers. Any questions so far? Okay, we'll move on. Yeah, also, if you have any questions, you can interrupt me anytime. No worries at all. Okay. I want to play this video and I did not link it. So give me 1 second. Oh, perfect. Way more people now.
Blockchains are incredibly popular nowadays.
Let me share my screen again.
But what is a blockchain? How do they work? What problems do they solve? And how can they be used? Like the name indicates, a blockchain is a chain of blocks that contains information. This technique was originally described in 1991 by a group of researchers and was originally intended to timestamp digital documents so that it's not possible to backdate them or to tamper with them, almost like a notary. However, it went by mostly unused until it was adapted by Satoshi Nakamoto in 2009 to create the digital cryptocurrency Bitcoin. Now, a blockchain is a distributed ledger that is completely open to anyone. They have an interesting property. Once some data has been recorded inside the blockchain, it becomes very difficult to change it. So how does that work? Well, let's take a closer look at a block. Each block contains some data, the hash of the block, and the hash of the previous block. The data that is stored inside a block depends on the type of blockchain. The Bitcoin blockchain, for example, stores the details about a transaction in here, such as the sender, receiver, and the amount of coins. A block also has a hash. You can compare a hash to a fingerprint. It identifies a block and all of its contents, and it's always unique, just as a fingerprint. Once a block is created, its hash is being calculated. Changing something inside the block will cause the hash to change. So in other words, hashes are very useful when you want to detect changes to blocks. If the fingerprint of a block changes, it no longer is the same block. The third element inside each block is the hash of the previous block. And this effectively creates a chain of blocks, and it's this technique that makes a blockchain so secure. Let's take an example. Here we have a chain of 3 blocks. As you can see, each block has a hash and the hash of the previous block. So block number 3 points to block number 2, and number 2 points to number 1. Now the first block is a bit special. It cannot point to previous blocks because, well, it's the first one. We call this block the genesis block. Now let's say that you tamper with the second block. This causes the hash of the block to change as well. In turn, that will make block 3 and all following blocks invalid because they no longer store a valid hash of the previous block. So changing a single block will make all following blocks invalid. But using hashes is not enough to prevent tampering. Computers these days are very fast and can calculate hundreds of thousands of hashes per second. You could effectively tamper with a block and recalculate all the hashes of other blocks to make your blockchain valid again. So to mitigate this, blockchains have something that is called proof of work. It's a mechanism that slows down the creation of new blocks. In Bitcoin's case, it takes about 10 minutes to calculate the required proof of work and add a new block to the chain. This mechanism makes it very hard to tamper with the blocks because if you tamper with one block, you'll need to recalculate the proof of work for all the following blocks. So the security of a blockchain comes from its creative use of hashing and the proof of work mechanism. But there is one more way that blockchains secure themselves, and that is by being distributed. Instead of using a central entity to manage the chain, blockchains use a peer-to-peer network and everyone is allowed to join. When someone joins this network, he gets a full copy of the blockchain. The node can use this to verify that everything is still in order. Now, let's see what happens when someone creates a new block. That block is sent to everyone on the network. Each node then verifies the block to make sure that it hasn't been tampered with. And if everything checks out, each node adds this block to their own blockchain. All the nodes in this network create consensus. They agree about what blocks are valid and which aren't. Blocks that are tampered with will be rejected by other nodes in the network. So to successfully tamper with a blockchain, you'll need to tamper with all the blocks on the chain, redo the proof of work for each block, and take control of more than 50% of the peer-to-peer network. Only then will your tampered block become accepted by everyone else. So this is almost impossible to do. Blockchains are also constantly evolving. One of the most recent developments is the creation of smart contracts. These contracts are simple programs that are stored on the blockchain and can be used to automatically exchange coins based on certain conditions. More on smart contracts in a later video. The creation of blockchain technology piqued a lot of people's interest. Soon others realized that this technology could be used for other things, like storing medical records, creating a digital notary, or even collecting taxes. So now you know what a blockchain is, how it works on a basic level, and what problems it solves. Want to learn how you can implement a simple blockchain in JavaScript? Then check out this video here.
Yeah, so I thought that was a really neat video, kind of explaining, giving a good overview of what blockchain is, like the more technical aspect. It does a way better job than I could of explaining what it is. So I thought that was a useful video to show. It covers some stuff that will be dive into further details in this lecture, and it covers some stuff that that will be covered in later lectures. So we can dive a little bit deeper into the structure of blockchain. Share my screen again. Okay, there we go. So this is what a blockchain looks like on a very basic level. So you have the header, a hash, which it talks about in the video, timestamp, a nonce, and block data, and each block is connected. So we're going to break down each section and kind of discuss what they are. So the first one is a hash. So a hash function is a cryptographic function that transforms a message of any size to a hash of a fixed size. So think QR codes, right? Like right now, we've been going to a lot of restaurants where you just scan a QR code and it takes you to the menu. So obviously the menu itself can be any size, right? It can be a 1-page menu, it can be a 10-page menu, but it transforms themselves into a QR code of the same size. The QR code is always going to be just that big. So QR codes, I think, is actually an example of just a storage function. So it's pretty interesting to think about it that way. So hash functions are one-way, deterministic, and non-duplicate. So what does that mean? So one-way means that the inputs will generate a particular hash, but not the other way around. So if I typed in ABC, my hash could be XYZ. But if I type in XYZ as my hash, I'm not going to be able to see my input. So that's a way that the blockchain is secured. So knowing the hash doesn't allow me to know the message or the input of the block. And deterministic means the same message will always produce the same hash. If I type in ABC, it's always going to give me XYZ. Even if I just randomly guess ABC, I'm going to be able to get that hash. And the last one is non-duplicate. So that's pretty straightforward. It just means no two hashes are the same. So a typical block in the blockchain contains the hash itself and the hash of the previous block. So each block referenced the previous one. That's kind of what the video is saying. In fact, this was just a screen grab. Oh, oops. The picture on the bottom, which is a screen grab from the video. So if the data within a block changes, the block itself will be different. So if the block is different, then obviously the block data is different, then a new hash will be produced. And if a new hash is produced, then the next and the subsequent block will not be able to reference the correct block. So that's how you kind of detect when a blockchain has been hacked. And that's what makes it really secure, because each block references each other. So yeah, exactly. So when this happens, a following block will no longer be able to reference, making it invalid. And that's a huge part of what makes it tamper-proof. Obviously, there's a bunch more other like cryptographic functions that allows it to be really secure, but this is kind of like the main idea behind blockchain. Timestamp, that's the other piece that's in the blockchain. So timestamp is a small piece of data stored in the block that determines when a block has been mined and validated by the network. So it can be used to determine the validity of the blockchain by looking at each block if they're added like sequentially in a proper sequence, right? Like if the blocks are, are timed right, I can't add something in July and then add it in June. That's really weird. So you can know if the blocks are added in the same sequence. Its main use does concern mining. So it helps networks to determine how long it takes for each block to be mined and adjust the difficulty based on the information. The time actually is kind of weird because we think of blockchain as this really, really advanced like technology, but the timestamps have often not very accurate and can even be off by a few hours. There's a reason why it's not a huge deal. And I kind of forgot why it's not a huge deal, but I believe in the case of Bitcoin, for example, they don't really care that the timing is off. It's not really a huge part of secures blockchain. If anyone knows why the timestamp can be off, feel free to jump in. But anyways, I think on a very basic level, it just records the time. It records the time when a new block has been added to a blockchain network. It's a little bit more applicable when we get to mining in the third week. Nonce. So nonce stands for number ones. And quite literally, it's a randomly generated number that's only used once. And it's very interesting to see how numbers are randomly generated. You think that you can just come up with a number and it'll all be the same quality. There's actually random number generators, and some are way better than others. I don't really know how that works either, but there's something I've heard from someone else, which I thought was pretty interesting. The companies that just run random number generators, and they do a really good job at it, I guess. So miners must successfully guess the nonce, attach it to the hash of the current header, rehash it, and compare it to the target hash. So if this is right, then the miner has successfully mined the block. So kind of to break that down a little bit more, right? So what we said about the blocks being one way, meaning that you have to kind of guess the input in order for you to get the right hash, right? So this is kind of part of the input. So the miners are essentially guessing, checking a bunch of nonces to see if they can get the hash of the block. And if they do, then they've successfully mined the block. So it's used for difficulty adjustments in mining. And we're going to cover this way more when we get to the lesson on mining. So right now, just a very brief overview. You kind of just need to know that it's something that exists in the blockchain. Last thing is block data. So block data can contain any information. It usually includes a transaction list, which is a list of all transactions previous to the block itself. And each transaction can contain a hash, making the block a lot more concise. So the hash function used, that's the most popular, is called SHA-256. That's a header, that's a hash used for the header. And the Merkle tree is also something used to condense the transaction hashes. We'll also talk about that a little bit later. I know we're pushing a lot of stuff off. Just want to give a really brief overview of what a blockchain is, but we're going to be talking about hash function, SHA-256, Merkle tree, and all that stuff in the next lecture about cryptography. So any questions so far?
I have a question, if that's okay.
Yeah, of course.
So when you say like if I mine, say I guess one of the blocks nonce and I mine that block, what does that mean? Like, do I take the data in that block and I can manipulate it in ways and stuff? Is that it?
Yeah. Okay. No, that's a great question. So that's kind of how mining works. So to give a really brief overview, I know Jacob's actually doing a presentation on mining, so I won't impede on his. I won't step on his territory. But basically, when you successfully mine a block, what you do after is, so we have this thing called proof of work, right, which we heard about in the video. So you send the proof that you've mined the block, you guessed the right thing, to the rest of the network. What they do is that they then confirm it to create consensus. And when consensus has been reached, that means what the block that you just mined can be added to the blockchain. So let's take Bitcoin, for example, right? So when you successfully mine a block of Bitcoin, it contains information that are rewards. So the reward is, hey, Carl, you mine a block in the Bitcoin network. Here's 6.25 Bitcoin, right? So when you share the proof of you successfully mined a block to everyone else in the network and they approve it, then that information is added to the blockchain. So they're saying, okay, Carl just became the new owner of 6.25 Bitcoin. And so that becomes valid and that stays in the blockchain. So what you're really doing is mining blocks, adding them to the blockchain and making sure that the information you're adding is right. And in that case, the information is money. So that just means you just got some money. So that's kind of how that works. Does that make sense?
Yeah, it does. Thanks.
Okay, no problem. Yeah, we'll touch on that a little bit later as well. So definitely feel free to ask more questions.
Okay.
So now we're going to go into some applications of blockchain. So we're going to be focusing majority of kind of the rest of our time here discussing blockchain and money, since it's the most prevalent use case as of date. So this will be a pretty high level overview discussing what money even is, the history of money, how transactions are validated in a society, how blockchain technology could challenge the fiat system. So like to me, I'm a commerce student, so this stuff is really, really interesting to me. And this is kind of the stuff that sold me on a lot of crypto stuff. But by no means am I advocating for any crypto or just crypto in general. Right? Like even though I'm going to reference some crypto like Bitcoin, not saying this is your note to go buy Bitcoin, like do your research. It's not investment advice. I'm not giving out that for free. So this is just showing you how blockchain can be useful in terms of money and also some other stuff. We'll also discuss some other use cases of blockchain, including ones that are popular now and some that might be popular in the future. So blockchain and money. So the purpose of money, there's three purposes. One is medium of exchange. So when, let's say, Jacob, like I want a coffee from you, I pay you $3, right? That's a medium exchange. There's storage of value. I want to store money in my bank account. I want to store it in the form of gold. I want my money to be valuable 10 years, 100 years, 1,000 years down the line. This third thing is unit of account. So just accounting like how much each stuff is worth, right? Like having a basis to regulate price. So that's kind of the three purposes of money. And some characteristics of money, right? So we have divisibility. So this means how easy it is to break down large units, right? Like let's think about like the Canadian bill. We can go all the way down to 1 cent, and that's kind of it, even though that's pretty small. But for Bitcoin, in the case of Bitcoin, it's infinity, right? You can keep breaking it down as far as you want. And durability is how long the money lasts. So this is kind of a weird concept to think like how long money lasts, but like gold, for example, can last for a really long time. And the reason why we want to think about it is that if you're using it as a storage of value, you want the money to still like physically be there in like 100 years, right? If I'm storing the value for my kids, for my grandkids, I need the money to actually still be there. So durability is an important characteristic. Recognizability is that how hard is it for me to forge it, right? Like it's pretty difficult to, well, I think it's pretty difficult to forge a US dollar bill. Like I've never tried it, but I heard it's hard. And it's really, really hard to forge a Bitcoin. It's basically impossible to forge a Bitcoin, right? So, and then lastly, portability. So can I transport this easily, right? This is for medium of exchange. If I want to spend my money, then I should be able to put it in my pocket, go to a merchant, spend my money. If I'm carrying around gold bars, that might not be the easiest way to spend my money, right? The last thing is scarcity. So how hard is it to produce an additional unit? So this kind of has a reverse relationship to inflation. And this is really interesting because what we've seen during COVID time was the US printed a lot of money. I think it increased its M2 money supply by a third or something ridiculous like that. And for minerals, right, like on the right hand side, we see some examples from money. Gold, for example, it's pretty hard to mine gold. So it's pretty hard to produce an additional unit of gold. So that makes it a little bit more scarce. Like for the shells, they're not really that scarce, right? They can be produced pretty easily. For the fiat dollars, I guess there's absolutely no cost of creating except for inflation, but we're going to talk about inflation later on. And for Bitcoin, there's only 21 million of it, right? And every time you mine, every 4 years, it gets way harder to mine. So there's a cap on the amount of Bitcoin. So there's a limit on the supply, whereas for a lot of the other assets, there's no limit on supply, which is a very interesting function of Bitcoin and very interesting to think why Satoshi kind of devised that method. And on the right-hand side, just some examples of money. You can kind of think about them in terms of how they relate to the characteristics of money, right? Like if we're looking at the shells, they're not divisible at all, right? So they're doing pretty bad on that. They're probably not that durable. Like if I leave that in my bed for like 100 years, it's probably gonna turn to dust, right? I don't know how recognizable it is. Maybe there's something special about it, but like to me, I can't really tell. And portability, I guess, fine. I can grab quite a few of them in my pocket, and it's probably not that hard to reproduce, right? So that's not a very good example of money. Gold, on the other hand, it's not that great to be divided, right? You can't really divide it, but it's very durable. It's very recognizable. It's not that portable, but it's quite scarce. So it's very interesting to think about different examples of money and how they fulfill the different characteristics. And this slide, I think, has a little bit more detail. So it compares Bitcoin to gold to fiat. I won't go through all of them. We're a little bit short on time, so I'm kind of leave that there for you to think about. But I think the 5 that I outlined before is the 5 most important ones. There's some other ones like established history or censorship resistance. They're not the most popular characteristics of money. So I think if you Google top 5, what I said before will come up. But yeah, we also have blockchain and money in general. So what is a ledger and why is ledgers important? So money is not particularly meaningful if there's no way to track transactions, right? So one of the most important purposes of money is the medium exchange. And without a ledger, this can't really happen, right? Money's not very useful if I cannot record that, hey, I just sent you money, you just received money from me, and in exchange, I got some goods from you. That's kind of the basis of our society today. So some attributes of good ledgers is that it's immutable, time-stamped, accurate, descriptive, and comprehensive. So if you recall to what the blockchain technology even is, it fulfills a lot of these criteria, right? It's immutable, it's time-stamped, the block data makes it descriptive, the cryptography makes it accurate, and it's quite comprehensive because it's decentralized and completely transparent. So blockchain itself is a very good ledger. So there's some examples, right? There's personal ledgers that we use every day. If I go to, I don't know, Starbucks, I spend $10, I have $10 in my Starbucks checking account, and they take it away, give me a coffee. That's my personal ledger, right? Or my corporate ledger, which belongs to a company, there can be multiple transactions. A central bank ledger, which is about governance and control, about how much money we lend out to different banks, right? Like how we're doing on our inflation, how are we doing on our risk, on our debt. So these are the things that central banks worry about. And then there's the Bitcoin ledger, which I think fills all the attributes of being a good ledger. It's also very transparent, that's open to everyone, right? Like the ledgers we see before, corporate, central bank, personal, it's all very opaque. There's not a lot of transparency there, and Bitcoin completely challenges that. So that makes blockchain to be a very blockchain completely challenges that and makes it a very interesting ledger to think about. And some alternative uses of blockchain. So I know we just spent, I don't know, the past like 5 minutes or so talking about money, but that's not the only use case. So there's NFTs, which are non-fungible tokens. Right now, art is really popular as a form of NFTs. There can be other things that can be NFTs. So this is kind of registering digital assets. Very, very interesting to make sure that the ownership is right, that the art is authentic and the artists are fairly compensated. There's healthcare. We can store medical records on the blockchain to ensure authenticity, so no one can tamper with it, and it makes transaction information much easier. It really revolutionized a lot of the outdated systems that we have in our healthcare today. And some of the future use cases, right? Like real estate. I think there are, I made this slide about a month ago. I think right now there are companies doing real estate and title registration on the blockchain. So I guess it's not even future use cases anymore. It's being developed. There's governance in terms of voting. If you think about our political system and maybe the US a little bit more, their voting system is kind of broken sometimes. There's often calls for like just, fake votes, this and that. So with the blockchain, if you can register voting on a blockchain, making sure that every vote is actually secure, this will be really interesting. And then cybersecurity is a very obvious one. It can help with data storage. So the key takeaway here is that blockchain is not crypto, right? It's not just about finance and money, even though I just spent the past 5 minutes talking about it. It does have important alternative use cases that are constantly being developed and could be very, very popular in the future. So I'll wrap it up here. If you have any questions, feel free to ask. If not, everyone will have a good night and welcome to the Blockchain Lab.
That's something I was curious about.
Yeah, for sure.
What is the reason behind the 21 million cap?
That is an excellent question. So why the number 21 million? I have absolutely no idea. Maybe 21 Satoshi's favorite number. I don't know. I have no idea. But the reason why they cap it, so there are two reasons. One is that I think Satoshi created Bitcoin for it to be inflation resistant. So Bitcoin is a deflationary asset because it becomes more and more rare as more coins are produced. And the second part of it is that every 4 years, there's a change in how difficult it is to mine an additional block and how much reward you get out of it. So I forgot what it started with. And the reason why I said 6.25 was because I think that's the current reward. Correct me if I'm wrong. I believe the last one was like 15 and now it's 6.25. So it divides by half every 4 years. So the 21 million cap, the reason behind it is because he wants it to be inflation resistant. He doesn't want it to be like the US government's fiat dollars where you can just print whenever you want, right? So he wants it to be a true scarce asset where there's literally 21 million and no more. Like you cannot make any more than 21 million Bitcoin. So when the supply of Bitcoin is capped, then the only thing changing the price is the demand. So if you can't print more of it, the only way that the value of Bitcoin goes up is if more people want it. And the thought process behind that is if it becomes more scarce, more people are going to want it, and then the price is going to go up. So that's kind of, I think that's maybe one reason why it's capped at 21 million.
Cool, thanks. And thanks for your presentation. It was really informative.
Yeah, thank you.
Hey man, literally just one question. So this is like really common with like, everybody talks about the benefits or like on how decentralization is like a big drawing factor towards blockchain. And that's like always what I said when people say like, what is the advantage to like crypto or anything like on the blockchain? I'm always like, oh, decentralization. And then in finance class, Blair was like, why is that a benefit? Like, why is it good? Like, why do you not want it to be a centralized entity? I can like control it and like prove it's like secure and therefore like, I don't know, you get robbed. It's like they can like back you up, blah, 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 blah. He said, where is their value in decentralization? I just wonder what your take was on like where like that decentralization actually like came in as like a good thing.
Yeah, no, absolutely. I think that's a really, really great question. And it's something that I've heard of before, right? Like, I think blockchain and crypto in general represents some sort of a rebellion, right? Like I don't mean it as like a full like civil war thing or anything like that, but I think it represents kind of a pent up like anxiety or whatnot against a very centrally controlled economy, a very centrally controlled way of life, right? So if we don't want the Fed to, have full control over our economy by printing money very aggressively, then decentralization is a great way to go. But also, it's really important to note that we're thinking from a very Western-centric perspective, right? Like if you look at where Bitcoin usage or like crypto usage is really popular, you're finding a lot of third world countries, right? Like El Salvador legalized Bitcoin as legal tender. A good reason is people just like, hey, I don't want my government to, steal my land, right? Like if my title isn't registered in the blockchain network, the government can literally just seize my land with no good reason at all. The government can print money basically to infinity, like what Zimbabwe did, and completely wreck their economy. So if you want to control your monetary policy, if you want to control your money, then you want to put it on this global network that's decentralized and not controlled by a single entity. So that's a draw for decentralization. So it's less of a concern for us, right? Like the Canadian government's pretty good at, I think they're pretty good at managing our economy, not completely screwing it up. But many people don't think that. And especially if you think about third world countries, then that's actually a very prevalent problem. So I guess that'd be my take on it. I don't know if it's a great take, but it's kind of just some of my thoughts.
Cool. No, I think that is a great way to look at it, especially like I wish I had the same rebuttal to Blair when he asked me that question, on how Blair was looking at it from the millionaire banker that he is, instead of something like Zimbabwe or something that can actually really benefit from like actually drawing away from the government, because that would give them more protection, not with the same like he looked at it in the sense of like, I don't know, your money gets taken from the blockchain, like you can't do anything about it, which is completely fair. And if you look at like MetaMask, like they have that big disclaimer at the beginning, it's like if you lose your money, like it's gone. And then some guy like turned up in the middle class and was like, oh yeah, I had some friend who lost his laptop or something like that, and therefore he couldn't access his decentralized wallet and he lost the money there. And then Blair was like, oh, exactly that. That's why like decentralization is not great. But then again, as well, like you can lose your wallet that has $500 cash in it and you can't get that money back either. So it's not a great argument on his side. And I like what you're saying there with bringing into like the more like global sense. But yeah, no, that's great. Thanks, Artie.
Yeah, no problem. All right, if there's nothing else, then everyone have a great night. Queens people, I guess Queens Commerce people, have good luck with your midterms. Yeah, we'll chat soon.
Thanks, man.